The Rusty-Patched Bumblebee of Minnesota. By Grace and Thielen. Bees have been on the decline due to a number of different factors such as disease, pest control programs, pesticides, agriculture intensification, habitat loss and environmental changes. All of these contribute in one or another in the declining bee population. The result from this decline in bees is that crops that require pollination are unable to receive their full pollination services from native bees alone. While focusing on monoculture self-pollinating crops may be economically viable, it contributes to the ever-expanding issue of providing an adequate food supply for crop pollinators. The lack of a proper food supply for pollinators has been proven to decrease the productivity of bee species. While this affects plants of all kinds, it also affects the beekeeping economy. While beekeeping was normally used for their honey production, it may switch focuses in the future to be an essential part of farming should bee populations continue to decline. However, of the world's 3,000 crops, only 12 make up 90% of the world's food supply. These 12 crops are largely self-pollinating through wind pollination or other methods and include rice, wheat, maize, sorghums, millets, rye, barley, potatoes, sweet potatoes, cassavas, maniocs, bananas, and coconuts. Without mentioning the aesthetic aspect of flowers, it may seem like the decline in bees and the subsequent lack of pollination will not hugely affect the global food supply. However, this is not the case. Hay crops such as alfalfa, clover, lespedeza, and trefoil are reliant upon pollination as they do not self-pollinate. These crops are essential to the diet of livestock. More than half of fats and oils, which are a staple of modern diets, such as coconuts, cotton, oil palm, olives, peanuts, rapeseed, soybeans, and sunflower are also reliant on pollination. Furthermore, the self-pollinating crops are also reliant on pollinating as insects collect nitrogen from the air and store it in the soil. This greatly enriches the soil and increases crop efficiency. Additionally, native bee species are incredibly important for non-cultivated plants such as grasslands, shrubbery, and herbs along with the aforementioned vibrant flowers. So, while at first glance it may not seem like the decrease in pollination will affect our food supply, looking at both animal and plant products reveals a different story on how valuable bees are. While determining the exact economic value of bee native species is difficult, it is undeniable that they are extremely valuable economically. It is estimated that wild bee species provided over $1 million in terms of worth. However, this calculation does not include the many other unobserved wild bee species and is not near a comprehensive number. But despite this, these wild bees are largely absent in agriculture-heavy areas and these areas instead rely on domesticated bees. While studying the beekeeping industry, it was determined that investing in bee populations to pollinate crops only provided a low rate of return on invest money. Farms now instead focus on more mobile rentable bee colonies that transport bees to temporarily pollinate the crops. So instead of keeping permanent bee colonies on every farm, they instead rent out temporary colonies. This practice messes with bee populations and creates an uneven distribution of bee populations across the states. The practice of renting out bee colonies is not ideal for either the bees or the crops they are pollinating. Due to the competitive nature of renting out bee colonies, the prices remain low for the beekeepers and in order to make a profit, the beekeepers cut corners in order to maintain high profits. This manifests in many ways such as an insufficient number of bees being provided for services or a lack of worker bees or the colonies being distributed in an inefficient manner. While one could make the case that this introduces the market for higher quality pollinating services, bargaining for more money and more protections for the beekeeper's bees is something that the beekeeper is often not in the position to do. With this in mind, we can look at land cover changes in Minnesota and determine what are some reasons for the decline of the rusty-patched bumblebee. This map shows the pre-settlement vegetation of Minnesota. It's made up largely of prairies, wetlands, and forests with some undefined areas. Bee prime habitats are also large prairies, wetlands, and forests, all of which pre-settlement Minnesota had an abundance of, making it an ideal habitat for bees. Out of Minnesota's pre-settlement vegetation, Prairies make up a large portion of bee habitats and are a vast portion of Minnesota's landmass. These prairies were prime areas for underground nests of the rusty-patched bumblebees. However, these prairies have been largely taken up by self-pollinating crops that do not require bee pollination. This portion of bee habitats simply doesn't exist as it did before settlement. Additionally, these crops brought bumblebees into contact with pesticides as their habitat was overtaken by crops. Along with this, tilled fields disallowed the bumblebees to nest underground. The crops that do require or benefit from at least some bee pollination are displayed here. These crops are vastly outnumbered by the self-pollinating crops and do not adequately substitute for the lost vegetation. This is not ideal, as although the crops themselves are unable to sustain a bee population, they still require bees to pollinate. All of this shows when examining potential bee habitats. Instead of settling in more natural or rural areas, higher potential is instead focused more in urban environments such as the Twin Cities and other smaller surrounding cities. Overlaying these two layers shows that higher potential bee habitats avoid self-pollinating crops and instead are more located within urban environments like the Twin Cities and other smaller cities. How have habitat changes affected the rusty-patched bumblebee, and where do they find their new habitats? Why do bees prefer urban habitats over natural habitats? There are a few theories as to why bees are more prevalent in urban habitats over natural landscapes. One of the major reasons for this is urban parks, which house a large variety of fauna, which essentially translates to food for bee species. Another theory is that bees are freer from natural parasites in these urban environments. Additionally, cities tend to be heat islands, which attracts bees suited for warmer climates. Looking closer at the Twin Cities, much of it is impervious surfaces, as urban environments tend to be. These concrete impervious areas absorb solar heat, and this contributes to urban heat islands. While this may attract bees that fit better in a warmer climate, there is a limit to what is ideal for bee habitats. Temperatures that are higher than 100 degrees tend to be too hot for the native bee species. As seen here, the high-potential bee habitats largely avoid areas over 100 degrees Fahrenheit. Although this may just be a case of bees avoiding overly impervious concrete areas as the habitat is not ideal for them, it may also be a case of bees avoiding areas that have too high of temperatures. Time will tell if urban habitats prove to be a more ideal habitat for bee populations. But regardless, efforts should be made to preserve bee population and stem the declining population of bees, whether they be location within cities, farms, or forests, as continued degradation of bee habitats will have negative effects on both the environment and the economy.